Alright, in this video I'm going to work out the very first problem on all the sample problem sheets. So you've got two worksheets, but each sheet's divided into two sections. I circled number 1 on all of them. So those are all the problems that I'm going to work out. Since I'm working them out for you and giving you all the work and the answers, I'm not going to grade those. Alright, so for molarity, the first thing you need to know, molarity is abbreviated using the symbol capital M, and it stands for moles per liter. So you can kind of think of this as an equation. This is our formula. And to be able to solve for molarity, we have to have a number of moles, and we have to have a number in liters. Another thing is if they give you molarity and they want the answer in moles, we can rearrange this. We can plug in the value for molarity, plug in the value for liters, and calculate for moles. So we can rearrange this to solve for whatever we need in each question. Another thing you need to know, sometimes they give us values in moles, sometimes they give us values in grams, and we know how to convert between the two. So if we have moles, we can use the mass from the periodic table to get us grams. And it works the other way. So in this problem, they give us grams, and we have to go backwards, get the answer in moles, and then we can plug it into this formula. Our volume has to be in liters. Just like in this problem, they give us the volume in milliliters. We have to move our decimal 3 times to the left to get it in liters. And I should not say liters equals milliliters. We need to change milliliters to liters. All right, so looking at this first one, copper 2 sulfate purchased for laboratory use is usually the pentahydrate, CuSO4 5H2O. This water of hydration must be taken into account when measuring out masses of copper sulfate. If 62.32 grams of copper sulfate pentahydrate is dissolved in 650 milliliters of solution, what is the molarity of the solution? We worked with hydrates when we did the stoichiometry lab. When you calculated the mass of them, you had to include the mass of your water. So on here, we're going to have to do the same thing. We have 62.32 grams. So according to this, we're going to have to change our grams to moles, and then we can plug our moles into the equation. So that's what we're going to do first. So I have 62.32 grams of copper sulfate pentahydrate, and I'm going to convert it to moles. So I'm going to look up all of these values on the periodic table and add them together, including the 5H2O. I know there's a dot there, and that usually means multiply, but for this, for the masses, we're adding them all together. So when you add them all up, you should get 249.72 grams, and we put 1 mole on top, multiply across the top, divide by the bottom, and you should get 0.25 moles. All right, so now we've got our top number. They give us 650 milliliters. Well, we have to have liters. So we move our decimal 3 times to the left, and that gives us 0.650. So now we've got our bottom number. So now we need to divide the two. You should get 0.38 molarity. And we would actually call this a 0.38 molar solution. And so molarity, it asks for what is the molarity. So our answer is 0.38 molar. All right, so that's 1A. So now look about halfway down the same sheet. Then we'll do 1B. How many moles of calcium bromide are dissolved in a 250 milliliter of a 0.3 molar solution of calcium bromide? So again, we know molarity equals moles per liter. This time they've given us molarity, they've given us our volume, we have to solve for moles. So we can say there's a 3.0 molar solution. We don't know how many moles there are, so I'm going to put X moles. And it gives us 250 milliliters. we have to move our decimal 3 times to the left. So we have a 0.250 liter solution. So now, do your algebra. We're going to multiply each side by 0.25 because we want x by itself. So when we multiply 0.250 times 3, we get 0.75 moles. And the question asks how many moles of calcium bromide. So now this is our final answer. If we were solving for volume, we would divide our number of moles. So you have to pay attention to the algebra. Some of y'all struggled with that with the gas law. So if you don't know how to solve for x, bring it to me and let me show you. All right, so now we're going to move on to molality. Be careful. Pay attention to the difference, molarity and molality. Oh, nope, we've got one more molarity problem. Sorry. Molality will be next. So now let's see, what mass of zinc acetate will remain behind if 86 milliliters of a 0.8 molar solution of zinc acetate is allowed to evaporate? All right, so this is still a molarity problem, capital M, moles per liter. All right, so they gave us 86 milliliters, so we have our volume, we have our bottom number. We have a 0.8 molar, so 0.800 molar equals, they don't give us moles, so we're going to solve for moles again. 86 milliliters, we have to change that to liters, so we move our decimal 3 times to the left, and we end up with 0.086 liters. We multiply those values together, and we get 0.0688 moles of zinc acetate. It doesn't ask for moles. It says what mass. We measure mass in unit of grams. So we're now going to have to take this number of moles and convert it to grams. And we do that by using the mass from the periodic table. So 0.0688 moles of zinc acetate one mole goes on the bottom. If we add up the mass of zinc acetate from the periodic table, we get 183.51 grams. So now we multiply across the top and divide by what's on the bottom. We get 12.63 grams of zinc acetate. So the question asks, what mass? Mass is measured in grams. So now this is our final answer, 12.63. Right, so now we'll go to molality. Molality, we use a lowercase m, so be careful with that, and it's measured in moles per kilogram. Most of the time our kilograms is water. So most of the time it's actually moles of solute divided by kilograms of solvent. A solvent is what does the dissolving. Usually in our solutions it's going to be water. So what is the molality of a solution containing 18.2 grams of HCl and 250 grams of water? So we're going to have to change our 18.2 grams to moles. We're going to do that the same way we've been doing it. 18.2 grams of HCl. Add up the mass of HCl from the periodic table. Multiply across the top, divide by the bottom. We get 0.5 moles of HCl. So that's our top number. And then it says 250 grams of water. For molality, we have to have kilograms. So instead of 250 grams, we have to move our decimal 3 times to the left. So we have 0.250 kilograms. So now this is our top number, this is our bottom number. We can plug it in. So you should get 2 molality, little m. Make sure you make that m smaller than you did for molarity. All right, and then the last one, sample E. How many grams of silver nitrate are needed to prepare a 0.125 molal solution in 250 milliliters of water? So we have little m equals moles per kilogram. They give us little m, they give us molality, so that's our 0.125. They give us our water, so that's our bottom number, that's our kilograms. One thing we need to know, and you can find this in your book in chapter 12, section 3, 1 liter of water is equal to 1 kilogram of water. So if we get 250 milliliters, we change that to 0.250 liters, that's equal to 0.250 kilograms. So a liter of water is equal to a kilogram of water. So if we have 0.25 liters of water, that's going to be 0.25 kilograms. So that's our bottom value. And then we have to solve for moles. Once we get moles, we can convert that to grams. So since we're solving for moles, we need to multiply 0.25 and 0.125. And we get 0.031 moles. And now we can take that value and convert it to grams by using the mass on the periodic table. Let me label this. So now 0.031 moles of silver nitrates. We put 1 mole of silver nitrate on the bottom. We add up all the masses, and you should get 169.88 grams. Multiply across the top, divide by what's on the bottom. You should get something close to 5.27 grams of silver nitrate. So the question asks, how many grams of silver nitrate? And we calculated grams of silver nitrate. So now that is our final answer.